Okay. Section this is, I think this is 9.3. Let me just double check, because I did skip around. So we are going to go into 9.3. I'm going to jump around here a bit in chapter 9 at the end of the year. This is solving quadratic equations using square roots. Solving quadratic equations using square roots. And we got to remember what we've been doing all along with our factoring in chapter 7, ax squared plus bx plus c. When we saw something in this quadratic form and we were looking to solve it, we were using the zero product property. We were factoring to find the roots, to find the solutions. We're going to be looking at, and we've talked about what we are doing today. I've introduced it. But to solve ax squared plus c is equal to 0, and notice the difference between these two. This bx term is not here. There's not that second x. All I have is an x squared. That's going to be very important. When I have that middle term with that x in something squared, or to the fourth, or even to the third for that matter, I want to try to factor to solve. When it looks like this, we're going to show you a way in 9.4 and how we can solve this factoring. But today we're just going to solve it by using square roots, taking the square root of both sides. There's some steps that go along with this. I'm going to say first, isolate x squared to one side of the equation. Back to equation solving 101. We want to get x squared by itself so we can solve it. Get it on one side or the other. Get it by itself. When you do that, you will get something that looks like this. X squared is equal to d. This d right here is just what I'm going to get. If I would solve this for x squared, I hope we can see I can subtract c, and then I divide by a. Now it doesn't even matter what this could be 0, this could be a number. But when I subtract something and then divide by it, that value will definitely change. We're just going to call it d. Whatever I get on the right or left side, when I have that x squared by itself, we're going to call that d today. And the last step, hopefully you can see, to undo something squared, take the square root. I want to know what times itself would give me d. Last step, then solve by taking the square root of both sides. Now let's just say of each side. Sounds better. Of each side. 3 steps. Get this x squared by itself. Take the square root. We're going to look at what solutions look like. And again, we have talked about this earlier as well when we were talking about rules of exponents. Solutions of x squared is equal to d. So now, once I have this isolated, there's some things that are going to hold true about the number of solutions I can get depending on what d is. When d is greater than 0. When is d greater than 0? Well, hopefully you're thinking to yourself, those are when d is positive. numbers that are greater than 0 are positive numbers. When d is greater than 0, I'm going to say x squared is equal to d has two real solutions. Two real solutions. And those solutions are x is equal to plus or minus the square root of d. So let's say this was x squared is equal to 4. Just going to jot that down right there. This looks like that. To solve it, take the square root of both sides. What number times itself gives me 4? Well, it could be 2, and also couldn't it be negative 2? We have talked about that. That should be review. Plus or minus the square root of d. When d equals 0, now you have x squared is equal to d, but this d is 0, it only has one solution. Taking the square root of 0 just leaves me with 0. So it has one real solution, and we know what that solution is. That solution would be x is equal to 0. When d is 0, I have one solution for x, and that solution will be 0. So we have it when it's greater than 0. As you can see, we're working backwards. Then we're down at 0. Now we're going to look at when these are negative, when d is less than 0. So if I take x squared is equal to d, and d happens to be a negative number, when you put that negative into your calculator, it is going to tell you an error because it has no real solutions. And we have talked about this previously as well. Remember, if d is negative, and this is a product of a number times itself, those signs have to be the same. To get a negative product, one of my factors has to be positive, one has to be negative. The only way to get a negative product is to multiply a positive times a negative. When I have 2 and negative 2, those aren't the same number. That's not the definition of something times itself. It has no real solutions, and we can say that. That will be our answer. When I isolate x squared and it's negative, you don't even have to put it in your calculator. Please don't. It has no real solutions. Let's look at some examples. 3x squared minus 27 is equal to 0. Follow your steps. Equation solving 101. Get x squared by itself. Well, x squared is being multiplied by 3, subtracted by 27. Just a little two-step equation here. I would add 27. 3x squared is equal to 27. Divide by 3. Now, I have x squared isolated. 27 divided by 3 is 9. Once the x squared is isolated, solve by taking the square root. And remember, with the square root, you will have two possible real solutions because that's a positive number, plus or minus 3. And I got it. Hopefully you are realizing the connection between what we did in chapter 7. If I gave this to you, you might say, I'm going to see if I can factor this, and you might already be thinking, if I take out a 3, I have x squared minus 9 is equal to 0. I have the difference of two squares, which factors into a sum and a difference of x plus 3 and x minus 3, and then using zero product property, I get a solution of negative 3 or positive 3. And I get the exact same thing. Which way is easier? I don't know. That's pretty easy when I recognize it, but this is as well. And you can start seeing the steps in your head. When I add 27 and divide by 3, I know that 9's a perfect square. I know it's going to come out nice and clean. We can do this in round as well. I'm going to flip my paper over. Look at the next example. X squared subtract 10 is equal to negative 10. Hopefully you can see right now, if I get this x squared by itself, this is that second property we had. When I get x squared by itself and it equals 0, and I take the square root of both sides, I know I have one real solution, and that solution is 0. And then our last one, you might have something that looks like this. Negative 5x squared plus 11 is equal to 16. And I can already see, this is giving me a hint right here. I know I'm going to subtract 11, which is going to give me a positive 5, and I'm going to divide a positive by a negative, which is going to give me a negative number. Let's see what it looks like. Negative 5x squared is equal to 5, exactly what we saw coming. X squared now is equal to negative 1, and because this d is negative, there is nothing times itself that gives me a negative product. When I see that, this is no real solution. It's not no solution, it's no real solution. This has a solution, and we're going to talk about that in days to come. Let's look at some more examples here. I'm going to change the way that these look, but our process is going to be the same. X minus 1 squared is equal to 25. I give you this on the Chapter 7 test, and I'm going to do it the way that we did it, but I'm going to do it the new way first. Because hopefully you'd be telling me, hey, Mr. DeLong, I need to FOIL that out or distribute that out, x minus 1 times x minus 1. I'm going to take that trinomial, subtract 25, set it equal to 0, see if I can factor it, and using zero product property get my solutions. Remember, when I have an expression like this and this is squared, this is just like a big, a giant x squared. If I square anything and it's in the parentheses, it's like one big unknown. Because this is squared, this is just like an x squared, I can take the square root. And this expression is by itself. Notice there's no number out front. It's not 3 times x minus 1 squared plus some number. This is isolated. It's a squared by itself. I can go ahead and take the square root of both sides right now, which leaves me with x minus 1 is equal to, well, the square root of 25 would leave me with plus or minus 5. I'm not quite done yet. I'm going to add this 1, and I'm going to set this up, put my 1 here because I would add 1 here, 1 plus or minus 5. And I can need to simplify that. I have 1 plus 5, which is going to give me 6, and I also have 1 subtract 5, which is going to give me negative 4. Those are my two solutions, 6 and negative 4. Now, if you did not recognize that and you did this like we did before, I'm going to write it out. I give you this on the Chapter 7 test, and most of you are going to do this. X squared minus 2x plus 1, and now I can subtract 25 is equal to 0. I'm going to do that to save time in one big step. I FOILed this out, and then I subtracted 25. I'm going to combine my like terms and look to factor. X squared minus 2x minus 24 is equal to 0. This indeed does factor. C is negative, so I know it's x plus and x minus something. Factors of 24 with a difference of 2, 6 and 4. And yes, this has to be a -6 because -6 plus 4 is -2. 4 times -6, -24. Using zero product property, solutions are -4 and 6, and I got exactly with what I did over here. Very convenient, especially when this D value over here is a perfect square. Both ways are correct. Remember, we factor to solve, but this is another way to solve these quadratics. And when I do quadratics now to solve, once I have all my tools, my toolkit, I choose what is going to be the easiest way to do it. You're going to get them, though, that aren't going to factor. And when I take the square root, they're not going to be perfect squares. And that's okay. That's why we have this trick. Not a trick, that's why we have this way of doing it, and we'll even look at another way of solving these quadratics. 2 other ways. Rules still hold the same. Get x squared by itself by adding 13 and then dividing by 4. 4x squared is equal to 15 plus 13, which is 28. I would then divide both sides by 4, and I get x squared is equal to 7. Take the square root. X is equal to plus or minus the square root of 7. That I just put into my calculator using my square root key because it's not a perfect square. Gives me, I'm going to go to the nearest hundredth. There's a tens, hundredths, 5. That would be 2.65. So I can say x is approximately 2.65. And yes, I put some wavy lines there. Remember, it's about 2.65. It indicates that number's rounded. We'll say round to nearest hundredth. And that's why we did that. It'll tell you, or I will tell you, how to round. Story problems come out like this, real life problems where we have to round. Could have something like this as well. 4 times x minus 3 squared is equal to 9. This is a question off of Chapter 7, Test 2. We had something like this. Just to simplify, you got to follow order of operations. I still have people taking 4 times x and 4 times -3 and then squaring that. PEMDAS, parentheses, exponents, then multiplication. This is multiplication between here. Exponents comes first. You would expand that out, multiply by 4, subtract 9, set it equal to 0, and then try to factor. Way too much work. Get this expression by itself. Remember, that right there is like an x squared. That expression is an x squared. X minus 3 times itself is what is going to give me 9, and I'm also multiplying that by 4. I need to get it by itself by dividing by 4. X minus 3, quantity squared, is equal to 9/4. I would take the square root of both sides. X minus 3 is equal to plus or minus, well, the square root of 9/4. That's a perfect square. That's a perfect square. Square root of 9 is 3. Square root of 4 is 2. I'm not quite done yet. I need to add 3 to both sides, and I'm going to set this up. X is equal to 3 plus or minus 3/2. I now have to do the math to get the solution. I am going to do 3 plus 3/2. 3 plus 3/2 is right there. Well, 3, if I get that, that's 3/2. If this is 6/2, I can add those together. 6 plus 3 gives me 9/2. I can also subtract it that way. 6 over 3, or I'm sorry, 6 over 2, which is 3, Subtract 3 halves now. 6 minus 3 leaves me with 3 halves or 9 halves. You will see quite a few of these, and they're always worth a shot to simplify. Look at the last one here. Just going to put a coefficient in front of that x now and what I am squaring. Certainly foiling that out, subtracting 36, using zero product property, too much work. You got this quadratic, this expression is isolated, it's squared, take the square root of both sides. How convenient, 36 is a perfect square. When I take the square root of both sides, it leaves me with 2x plus 1 is equal to plus or minus 6. This is a two-step equal in that, so you're going to have, I need to subtract 1 from both sides, right? 2x is equal to negative 1 plus 6, or I'm going to have 2x is equal to negative 1 subtract 6. Hopefully you see that. When I subtract 1, just what I did here, this would be x by itself. Like over here, I set up the 2, the little path, getting me 9 halves. You still want to set that up, but notice this x is by itself. I'm going to have to take whatever sum or difference I get here and divide it by 2. 2x is equal to 5. I would divide by 2. X is equal to 5 halves. 2x would equal negative 7. I would divide by 2. X is equal to negative 7 halves. And you got them.